Let's learn how to tell the difference between a proportional and a non-proportional relationship. We've discussed it a little bit, but let's go ahead and formally define it. So if a relationship is non-linear, meaning if it's not a straight line, it's non-proportional. But if it is linear, if it is a straight line, it could be either proportional or non-proportional. And the way we can tell which is very simple. If it goes through the origin, meaning if the relationship contains the point 0, 0, it is a proportional relationship. So proportional relationships contain 0, 0. Proportional has 0, 0. The origin, non-proportional doesn't. So what I'm going to show you in this video is how to tell if something is proportional when you're looking at an equation, a table, and, to start off with, a graph. And we're going to start off with a graph because a graph is the easiest. When you're looking at a graph and you're trying to determine if the relationship is proportional or non-proportional, your eyes should immediately zero in, literally, on the point 0, 0, the origin of the graph. So when we look at this graph right here, we are zooming in right here on the origin, that point 0, 0. Does this line go through the origin? Yes, it does. This line goes through the origin. So because this line or this relationship contains the point 0, 0, it is proportional. This relationship is proportional because it contains the point 0, 0. That's it. That's how we know it's proportional. It has 0, 0. So that's how you can tell from a graph. You look at the graph, you find the origin. Does the line go through the origin? If it does, it's proportional. If it doesn't, it's non-proportional. That's how you tell from a graph. Let's look at an equation. This says the number of years since Keith graduated from middle school can be represented using the equation y equals a minus 14, where y is the number of years and a is his age. Is the relationship between years and his age proportional or non-proportional? The way you can tell from an equation is whether or not there is a number, a constant in the equation that is not attached or being multiplied by the variable. Our slope-intercept form of an equation is y equals mx plus b, and our proportional form of an equation is y equals kx, and the difference between these two, other than one uses m and one uses k, is that plus b on the end. In fact, sometimes we have said a proportional relationship is y equals mx plus b, but b is 0, meaning it does not have a constant added or subtracted onto the end. So this is what proportional looks like, and this is what non-proportional looks like. So when we look at this equation, y equals a minus 14, it does have a constant added or subtracted onto the end. It has a minus 14, which means if we were to graph this relationship, it would have a y-intercept of minus 14. Well, to be a proportional relationship, it needs to have a y-intercept of 0, 0, the origin. So y equals a minus 14 is non-proportional because the y-intercept is 14, not 0. And that's how we know from an equation that a relationship is non-proportional. The last thing is looking at a table. So when we're looking at a table, this requires sometimes a little more math from us. This is the values of the US dollar 3 tourists traded for Mexican pesos. And we know the relationship is linear. Is the relationship proportional or non-proportional? Well, one of the ways that we can tell is by finding the starting amount, the initial value. Is the initial value going to be 0, 0? If you think about this logically, this is I traded $130 and I got 1,690 pesos. I traded $255, I got 3,315 pesos. It makes sense that if I gave you $0, you would give me 0 pesos, right? If I give you no money, you're not going to give me money, right? But sometimes it's not as easy to sort of logically suss it out like this, but there is another method to tell if a relationship is proportional, and that is when we do y divided by x, that tells us the value of k. Our constant of proportionality is k. If that constant of proportionality is constant across all of these values, that would also indicate that the relationship was proportional. Meaning, if we do 1,690 divided by 130 and get an answer, if that answer is the same as when we do 3,315 divided by 255, and that is the same as when we do 6,565 divided by 505. If all of those are the same, that would also indicate that the relationship is proportional. And if even one of those is different, then the relationship would be non-proportional. So 1,690 divided by 130 is 13. So what this indicates is that the exchange rate is 13 pesos per dollar, meaning $1 is worth 13 pesos. 3,315 divided by 255, and be wise to do this on a calculator because this is a pretty meaty division problem. Did I say 13 and wrote 130? Duh. This is also 13. And surprise, surprise, 6,565 divided by 505. You ain't gonna believe this. It's also 13. So the constant of proportionality here is 15, and because it is the same across all three of these ratios, this relationship is proportional. So the relationship is proportional. Why is it proportional? Because the ratio of pesos to dollars is constant, meaning the amount of dollars I give you does not change the number of pesos I give you, which when you think about it makes a lot of sense. If I give you $100, you're going to give me a certain amount of pesos for it. If I give you $500, you wouldn't say, oh, well, since you're giving me 500, now your dollars are worth more or your dollars are worth less. The dollars are going to be worth the same no matter how many you give me. That's what a proportional relationship is worth. They don't become worth more or less because of the amount you give me. That's proportional.